Hello guys, my name's Bonface Munyoki, and I'll be walking through Guix past and some of the concepts behind it. So, the first thing I want to check off during this short presentation is like the motivation behind Guix past and why it's important. Like, uh, what happens to old packages when they are no longer maintained? Like, what happens to them? What happens if you come across an old paper and you'd want to reproduce it? And also outside academia, like thinking production systems. Uh, I think it would be really cool if you had the ability to like go back in time and run a specific software from a specific time. So, for example, it would be really cool if you're able to like run VLC from say 20 years ago. I don't know if it's that old, but I'll just like use VLC as an example. I don't know if it existed 20 years ago, but it would be really cool if you were able to run like it from like 20 years ago. Or like for large software systems, large software systems, for example, Wikipedia, the software that runs Wikipedia. It would be really cool if it'd be able to go back in time and then be able to run specific version of Wikipedia from say to like 2007 or something similar. Yeah. So this whole area of software reproducibility has been a problem that a bunch of people have wanted to solve. So an example is like this chemistry reproducibility thing. Let's just go to Firefox. Um, Scroll upwards. The computational chemistry. A while back, there was like an error. People weren't able to reproduce a paper from chemistry, and it had weird like bugs, and a lot of papers referenced it. So uh, it brought like a shadow of doubt to work that was based off said paper, and it was because of a small computational error. So the ability to package old software and then providing people and just like making it more accessible to scientists is one of the main big driving factors behind Geeks past. And one of like the packages or like one of the things that these guys are trying to do is being able to like reproduce papers. And one of the what's this thing called um, one of the like submissions people are trying to like one of the journals that supports this is the Rescience journal, as you can see here, and you can have a look at some of the submissions people have. Let's see, yeah, like here are some of the submissions people have. You can see sim grid over here and a bunch of other cool and neat stuff. So back. So before we get into like the nitty-gritties of like how Geeks past works, we have to tackle like what Geeks is. So Guix is a functional package management tool based off Nix. It's both a functional package manager and a distribution. But for the point of this presentation, we'll be discussing Guix, the functional package manager. It differs with Nix. It differs in Nix in how or like in what programming language it uses as its DSL. And here it uses Guile scheme. So Guile is a dialect of scheme. So the advantage of working with Guile in Guix is you learn Guile once and then you can use it like all over the space. And of course, since Guix is like a GNU project, both Guix and Guile are like GNU projects, it means they're like free and free with like no constraints, free as in beer. So for people who want to like package non-custom software, like or software that don't contain GPL compatible licenses, you could also use channels to do that. And in fact, Guix is a channel. So you notice with Guix, you'll be building a lot of packages. When you define a package, you'll be like building it. But inside Guix, if you don't want to like build things all the time, especially when you use Guix on a day-to-day basis, you can always use farms and like substitute servers where instead of building a package, you just download the binaries and use it as it is. So I want to give a short demo on like a short demo on like a Guix package or like interacting or using Guile in Guix. And for that, I will just go to my terminal and let's go to the presentation. Yeah, so for this specific presentation, we'll just like interact and like see or like query a single package definition. So a bit of context. I will open the Python, the package definition, which is this guy, Python 2.4, and we are going to like see some of its like definitions from within Guile. So please bear with me here. Like in the next slide, I'll discuss what a package looks like and how it's defined. But for this specific section, we'll just like have a quick look at interacting with things with Guix from Guile. So for that, let's go to our terminal, and then we'll get into like our REPL, our Guile REPL. So Guix has this nice or like pretty way of loading things for us, which is like Guix REPL, and then I pass the path to where my module is, in this case where the Python has been defined. Get into it. We are into our REPL now. Load our necessary modules. Let's see, yeah. And now I'm going to create this open connection fella over here. And what that does is it gives us access to the Guix store. So how Guix works is I have to like show you this. So let's do that. So how Guix works is everything is stored in a store. Everything you build or download will be stored in one store, and no one has access to this store. Like I can't do like let's do store z. Let's do some random deletion here. No, not deletion, ls minus la. And Guix, there like no one user can delete things from like the store. How you interact with the store is using a Guix daemon. That's the only way you like interact with the store, and that has some advantages because it ensures integrity like with your data, which is like really cool. Anyway, let's go back to our REPL. Now we've created our store. let's get our Python. Let's define our Python. Define python and python -24. So this is like our package. So I've just stored this in a variable p, and then so this is a record type. This guy Python 2.4. This is a record type, so we can query details about it, e.g. like package name p, get the name, and then we can get the inputs like package inputs p, get all the inputs for like our specific package, and also can get all the data. So for example, in our case, you can do like a package to bug p and get all the data that will go to like our build system. So more of that later. So let's go back to our slide. Channels. So earlier on I mentioned that you could define your own channels where you specify the packages you need, like specific packages that are not provided by Guix upstream. So in the Guix ecosystem, you'll have like your main repositories, like your main curated repositories maintained by the core Guix developers. But you'd find that like some packages, like packages you may need, like packages that don't have the appropriate licenses, or packages that are no longer maintained. Like what would you do? Inside Guix, you could always do like you can use like a time machine to go back in time and get packages that are no longer in your current tip of your Guix branch. But the problem with that approach is Guix isn't that old. Guix time machine only reaches to a certain point. So let's see what that point is. I think the Guix past guys have like mentioned it somewhere here. Yes, Guix didn't exist in 2010. So what would happen with like packages that were not defined? Like what about packages that existed before 2010? How would you access them? So channels provide like a neat way of defining those packages in their own like user space. So here's an example of like a package definition. So we have our channels. We have like the Guix past channel, and then in my case I've added like the Guix bioinformatics channel, which contains packages for the G network, something that like I'm working on. So when I run a Guix pull, it'll update all my package collections with definitions from this site, from these two guys, Guix past, Guix bioinformatics, and it goes without saying like the main Guix package definitions from the upstream branch in Git Savannah. So that brings us to like our next topic. How do we define a package, and how does our package look like? So let's go to like a very simple example of like a package definition, a hello world definition, like a hello world program. For that, we need to go to like our terminal. Let's quit this guy. When I type a command hello, like this command does not exist. So what we're going to do is just like define a very simple package, hello, and then in our package you'll always have your package name, the version number, what's this thing called, the origin, which defines where you're getting it from, the build system. In our case, it's like the GNU build system, which is make install, like is it like .configure, make, and then make install. Synopsis, description, homepage, and finally license. Then let's go ahead and like run this. So installs package list, install from 5. Yeah. So before we build this, I wanted to like show you guys the whole Guix, the functional aspect of it's, what do you call it, Guix, like why we say Guix is a functional package manager. So right here we're installing a version 2.1.2.10. so let's search for this package from upstream, hello, and see what version they're using. So they're using like a 2.10. Let's build that from upstream. Guix build hello. So what Guix build does is it just like builds the package without installing it. So as you can see, like I haven't installed it. Now when you install it from the file, install from file. It's building the Hello World program. Let's just give it like a moment for it to complete. But once it's finished building, you'll notice it will use the same, it should use the same store, the same item from the store here. So let's list install hello, and yes, same exact thing, and we built it like you. So that's like how you define a package, and this is useful in understanding how Guix is set up. So let's go back to presentation. Now let's dive deeper into Guix. So by now you have some idea of what a channel is, and also like how a package is defined. So with that, what Guix really is just like a set of package definitions. So it's a channel that provides, it's a Guix channel that provides deprecated packages. So in there right now we have things like Python 2.4.6, NumPy version 1.2, 1.1. We also have matplotlib. It also like provides, in addition to like deprecated packages, it also like provides no longer maintained packages like in upstream, but this is inaccurate. So it just like provides deprecated packages, more so ones that were not present in before 2010. So we also aim, or rather, other packages that may find their way into like Guix upstream would be like packages that are not present in packages are not present or are not like required in the upstream Guix, but then are like no longer maintained by anyone. So you can think of them like orphaned packages. So right now I can't come up with one single concrete example, but I hope you get the idea. So I'm going to do like a short demonstration of having different Guix, like showing how you'd work with like the old packages. Like let's say you've set up Xpast in your machine and then you need to like work with like the old packages. I can show you like one example workflow, and for that I wrote a very simple script that just prints out the Python versions. So the script is like a matplotlib version, and what it simply does is prints the Python version and then the matplotlib version. So let's go ahead and do that. So the command I'm going to use is like the Guix environment, and then this allows you to create a special development container from which you can work with the packages installed. So for the first version, I'm just going to use the normal Python 3.8 with the latest matplotlib. Let's see what we get. So let's get into that environment. Yeah, so now we are inside the Guix dev, as you can see here. So let's run Python. So you can see we're running 3.83, and then matplotlib, we are on version 3.12. So let's exit that container. Now let's run the Python 2.46. Let's run the same command. Python matplotlib version, and voila, we see we're using Python 2.46 and we are at matplotlib version 1.10. So if you're trying to like reproduce a paper, you could just like use this environment and just like run everything inside this environment. Yeah. So so I want to discuss one single like problem I ran into like while working on Python. So for old libraries, people had coded things. So an example is like in matplotlib, when you're building the library, they had coded these base directories, these guys. So Linux 2, Linux 2, Linux 3, Linux, and in the current Linux in the current version, in the current Linux, like the kernel I'm using, they never foresaw like someone running a kernel version 4, like version 5 or like version 6 when it comes out. So when you try to build this thing without patching the actual Python 2.46, you'll get like a weird error. So I think that needs like some explanation there. So what I'm going to do is I'm going to comment out the patch, this patch over here. I'm going to comment out this patch. What this patch does is, from Python 2.46, if it does like a system.getPlatform, instead if it returns anything like that's within like Linux 5, Linux 4, Linux 5, Linux, this will just like replace it with a string Linux. So that will enable the matplotlib library to be able to be compiled smoothly. So I want to like comment out, let's see, I want to comment out the Python, the patch Python. So yeah, I've actually commented it out here and then build it. st. So let's build it. Exit build -l. Yeah. cd Guix. So let's just like wait for it. It should take some time. I had already built it a while back, and my output was something like this, Python 2.46. So anyways, while it's compiling, let's go to the Python definition and discuss some of like Guix flexibilities. So one of the things I like about Guix is that you could like patch things, and also it gives you the flexibility of like just configuring your build process. As you can see here, so for this specific build, I just like added a single patch that, yeah, so we're done. We are done. So this is our Guix store. So a bit of explanation here. A Guix build will just like compile everything but won't install the binary in your Guix profile. So I don't have this anywhere unless I decide now to pass in the install flag. So for this guy over here, let's try running this the GNU store, where the store is in Control C. Let's run that and see version. It's something weird we're doing. Yeah, that's a directory, so we have to go to bin Python and version. Python, let's see, help version, and we are in Python 2.46. so let's go ahead and run our matplotlib version program. I'm going to comment out the matplotlib versions, because what I want you guys to see here is like what happens if I do like a print, let's do like a platform version, then sys get platform. Let's run that guy and see like what we get. st, and then something I'm doing wrong here. Get platform. Let's just go back to the get platform. Just a moment. Let's do a py. Yeah, sys.platform. That's the command. So in fact, we can just get into Python, import sys, then print sys.platform. So you can see like we get like a Linux 4, but then that hasn't like been hard coded here. So let's go back to our journal.org file. So I really like Guix because it gives you the flexibility of applying patches, updating your build, also like troubleshooting, and also like getting into like a Guix environment. And as you can see over here, like updating, like being able to like build something from way back, and then being able to like test it. So let's get out, and then let's uncomment out the definition. Let's uncomment out this guy. Yeah, then you can just like build him again and see what we get. So you'll notice like once you apply the patch, like our Python version, will just output Linux, and then our matplotlib will be able to compile because we no longer have we'll use like an element which is inside this dictionary here, Linux, instead of like Linux 4, which doesn't exist there. There are like some weird problems when it comes to like building older software in modern hardware, and I'll highlight like one of them that like we came across 2 weeks ago, and we haven't like really been able to fix. But it's cool to be able to run into like such problems, and we are done. So let's just go here. No. So let's get inside this guy, Python import sys, then sys dot platform Linux, and that's pretty dope. However, like there are some weird unique problems we've like run across. So like I want to highlight one problem when it comes to like working with like old software. So let's go to our issues. Yeah, so one of them is like you have to deal with this. Python 2.4 doesn't handle overflow in integer exponentiation. So what that means is when you do like a 2 to power 64, you get a 0, and that's like weird. So it's there are like some weird niche challenges that people working on Guix past come across because of the nature of old packages that we need to like figure out, or like figure what to do, or like how to tackle them. But nevertheless, that has been like a walkthrough of what Guix past is, what you're trying to do, and then like where Guile comes in, more so in the context of Guix. And with that, this presentation is pretty much over. Finally, if you like want to like reach out to people working on Guix, you can always find us in Guix and Guix HPC on RC. There's also like the Guix Devel mailing list, which is pretty useful. So I hope I hope this talk makes sense, and I hope I've been clear. Yeah, and that's pretty much it. I hope more people get to use Guix more often. So adios.